Hello everybody, welcome to another stream. How are you doing? I've been here this early to see the logo. What is the R in the area of wedge shading? Um, so in reference to the starting screen. Yeah, I see what you mean, it's like the black. So it's basically a voxel ray traced. So we take the image and we extrude it out in the third on the Z dimension. And yeah, just ray trace it as voxels. And I don't know why. Where would that be? Yeah, it's probably the ray marching code for the voxel code is probably wrong. There's probably something where I'm skipping too much or I don't know. Yeah, I have no idea. Some bug. Yeah. How's it going, Taylor? How have you been? Good to see you again. You know, so I'm standing up and my green screen does not quite account for standing up me. So that's something I'm going to fix. I'm going to take my green screen, it's laid out horizontally. I'm just going to make it go vertical, and then it will be able to adjust for sitting down and standing up. But yeah, that's something I'll do later on. I just got my treadmill, so this is why I'm standing up, is because I can't be bothered to crank my desk down again. So yeah, treadmill's at the side. I still got to get a table because a table to put my keyboard on, because my desk doesn't quite go up tall enough for me when I stand on the treadmill. So that's coming. It's in the post. So last stream we decided that we're going to port AMD's single pass downsampler because I've written some downsamplers in the past. I'm not going to do a good enough job anyway, so I might as well port this one over. I realized that it's not quite a single header and it's kind of split across a couple of files, maybe a few files, and also the CPU code is in a bit of a different place as well. They do this because they've got like HLSL and GLSL support, and they've separated into different headers and things. And I still think you can do it in a single header, but anyway, that's the way they did it. But yeah, the traditional approach is you do one pass and you downsample a texture down to half resolution, then another pass, and then another pass. And in between these passes, you put a barrier, and that means that all of the work from the previous pass has to finish before you start the next one, so you have idle compute units and stuff like that, right? So the single pass downsampler does it all in a single pass, but it also writes out to all the intermediate MIP levels as well. So it takes this high resolution image and it'll produce all these MIP levels in a single pass. So it does it by taking a 64 by 64 patch. I forgot what else they call it. So each thread group gets a 64 by 64, and it downsamples that to a single pixel. And so you've got many of those that it does independently, basically 64 pixels by 64 pixels. Takes that down to a single pixel. So that gets you down to, so this single pass downsampler supports up to 12 MIP levels, which is a 4K squared resolution texture down to one pixel in a single pass. But if you take 64 squared and downsample that to a single pixel, you get that's 6 MIPS. So it actually does that method 2 times in a single pass. So you can obviously modify this technique to make it go to higher resolutions than that. So that's always something we could do in the future, but there might be some limitations to modifying some of these things because they might depend on like wave sizes or something like this. So yeah, we got kind of halfway through porting it over. It was just basically deleting a whole bunch of code and making it use the HCC wave intrinsics and atomic stuff, and figuring out where some functions are declared because they're all kind of a bit all over the place. So we're making our own AMD downsampler.h, where it's just basically their code just done, but with a load of stuff taken out. replaced. And what else? Yeah, we're going to be making it such that all we have to do is declare maybe a couple of things like the texture format, and or maybe they declare like a load function as well, so you can choose how it gets loaded. I don't know. We'll see. We'll figure out how do we basically template this header, right? So we can make optimized shader code for a very specific texture or something like this. Because when you downsample it, you have a choice between minning or maxing or taking an average, but maybe we can make this a custom thing. You know, so this is something we're going to explore today, and hopefully we get finished with it, you know, or at least on the tail end of this, finishing this. Because this will be super powerful. Although the only downside to this approach is that you don't have one. Yeah, you'd have to keep creating more and more shaders every time you want to do a downsample. So we're just gonna have a bit of a play. Sorry, a different type of downsample. Yes. Gotta start streaming again a bit. Awesome, amazing. Everyone should follow Taylor. Taylor makes video games. He's actually made a video game as well. It's on Steam. What are you streaming? Are you a new fresh code base in C? No way. You're making the jump. Because I remember you used to use C++, isn't it? That's cool. Amazing. Yeah. C23, like, it's got like, I think a handful of features where I'm like, oh, they're pretty nice, but the rest of them are like, they don't really need to get added. But yeah, you know, these days using like the latest C standards probably not too bad. Should be right. Yeah, I think it's C11 or maybe 17. I have no idea. On MSVC, they only recently started supporting 11, I think. That's really cool. That's great. You get to port your new code over. What made you start working on stream again? Have you got like a new idea that you know, or yeah, because I know you basically just been working, isn't it, and just been doing other stuff for this time. You made your game and then got a real job, and well, not a real job, it's still a game dev job. Yeah. It's one or two things that maybe we use not much. Right, gotcha. Yeah, there's a hash embed thing, which is pretty neat. Pretty neat idea. When I flow streams, the codebase inspired the proper transition to C, but I've still meaning to get some things worked out in terms of multiple compilers, ISOs, etc. Right. So the way I typically do that is just use Clang, but I use the pedantic extension. So, but I do check if ever I'm doing something that there is some version support in MSVC, but I don't actually try and support it because it's just I just see it's kind of pointless basically. You know, like there's like the hash pragma once, right? That's not standard, but it's supported everywhere, right? Stuff like that, or some intrinsics like debug break, stuff like that. Yeah. What else? But yeah, Clang's pretty much just used everywhere. You can just support Clang. I think the only platform that might not have it is a console, which I will not go over which console. It's quite easy to guess, I guess. Also, I want to do some code generation stuff to solve some type introspection kind of problems, like networking serialization of structures. Yeah, that's the real I've ended up going for as well when it comes to serializing data. Just have some form of like code generator, or you know, I've ended up making my code generator also output some type info, or I'm in the process of doing that. But for serialization though, it's going to be all code generated. But for other things, I think I'll use the type information, just because running a code generator all the time and having all these separate files is a bit annoying just for a little bit of code. But yeah. But for serialization, I think it's definitely handy having code generated stuff, because you can put breakpoints in and see the data as it gets put out to disk, and help verify like, oh, so it is this number before it got put out to disk. Rather than trying to chase it around in some generic code, which is going off. So yeah. Right, so we downloaded the Fidelity FX SDK. So I want to look out for, so there's a file where it's implemented some of the, maybe I can look up in my history, thanks to Fish. Probably do this in Bash, but it's, oh no, not this one. Well, yeah, so there's these files, but there's one where, well, I could just go into the project with Helix, and I'm kind of looking for, it had like mid-mip, I think was the terminology. It downsample, yeah, this is it, I think. So in here, there's, I want to find that sort of like constant buffer or something like that. Like, where is that? Or is that in the HLSL side of things? I want to see what parameters they pass in basically for the, right, SPD constants, this boy. Right. Number of MIPS. Work group offset. Yeah, they have this offset thing that they support. It's interesting. So you can downsample just an offset. Doesn't seem that much. Wait, sorry, this is FSR 2. Right, inverse input size used by linear sampling mode. We got rid of that feature from R1. Right. All right, so we'll leave this open. I think let's just go back. So yeah, I think we just need a number of MIPS. So this is our constants that gets passed into the shader. There'll probably be some more things. So it's got all the MIP levels, so you can run them back out and stuff like that. Cool. Right, so increase atomic counter, get atomic counter. That was one of my main walls I hit with my previous game project, where I wanted to add multiplayer. Right, there's a guy didn't have any code in Bash yesterday. Oh wow, I had no idea Bash could do so much. Yeah, I always find it difficult to find like documentation on like shell script without it like going into Bash. But yeah, like people do a lot in Bash, but it's just such an error-prone language. You have to be an absolute, you have to really know it if you're not going to make mistakes. Like, it's super error-prone. And obviously it's also prone because it's a scripting language and you have to run the code to see what's going on. See if it even worked. Right, so single pass, downsampler, reset, atomic counter. Right, okay, cool. We'll define our, right, these are our, let's just move these up here. So that's what the pixels get preloaded into basically. So we might get rid of some of these functions or just inline it all. I don't know what we'll do. We'll see. Or make some of them have to be implemented outside. So load, yes, this does this load source image and load 6, right? 6 is the middle MIP. I'm thinking that maybe, all right, okay, so maybe I think, so some do a load source image, some do a load. Maybe we could just say load and then you pass in a MIP, but it only will pass in 6 or 0 basically. We'll just do that. Just leave it as it is, right? So we need to make sure they pass these constants around because that's the limitation of the shading language. Right, so store radio load intermediate XY. Cool. Right, reduce. Neat. Okay, so I guess let's just go through the code and just make sure it all makes sense, and then we'll see what we can do about these user-defined functions and how we're going to make it so that we could define our own format before we include this header or something like this, right? And how do we maybe put things on the end of these functions so they're not all names the same or something like this? I don't know. Because we've just got a single shader binary that gets compiled. We just compile a single file. And that's all of our shaders in there. And if we're going to be like code generating specific downsamplers for specific formats, then we need to make sure that they have, the names don't clash. That was making a multiplayer game in Bash. Oh my days. I'm not sure what was harder, right? Bash or assembly? You know. Right, so what to do next, eh? I think we went over this before and it was all, well, no, because you have to like, oh, well. Right. Okay, remember, yeah, we went over this and we kind of looked at it and sorted out a lot of the syntax errors and stuff like that. So it's just a case of like, if we, right, and there's that downsample you call by passing in these guys, right? So we obviously need like some compute shader here. So I guess let's get that bit in, right? What's that, the compute shader which gets, right, and then we've got to pass in those bundle constants around, right? So we'll start from the entry point and we'll pass it all the way through. Yeah, so we'll do all that. Yeah. So, okay. So let's go to the source code and we're looking for, so if we look for, I guess this, we should find one of the single pass downsampler single pass downsampler. Well, where would it be? I guess we can search something else. So we look just for downsample, I think all in one word. Like that. Maybe not. Just everything has a downsample. But yeah, there should be a shader. SPD. But I could just search for this as an SPD downsample. That one, that's it. So SPD downsample. We're trying to look for where the entry point. Yes, this is downsample all in caps here, right? And then if it's got half support equals 1, which we completely ripped out the half support stuff because we don't really need that. So we're trying to look for like this here. Boom. Yeah, so here's the entry point. So this is for GLSL, HLSL. So look at HLSL because we basically use. Right, so this just declares a whole bunch of macros and stuff that we could probably just get rid of. So let's just, well, we can't really yank that because I'm in the. Right. So the width is 256, height is 1, depth 1. Gotcha. So let's go into my graphics shaders, and we're just going to locate the nearest compute shader. Drop that in there, so it's 256. For now, we'll just call it SPD downsample. Graphics compute shader, single pass downsample. Wait, it's SPD in it. Right, AMD downsample, done. Cool. So our push constants are called SPD BC. Nice, so those will get passed around hopefully. And all we're looking at doing is calling, you bugger. Prefer wave 64, blah, 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 blah. Wait, there's a prefer wave 64 thing you can do within HLSL. When the hell is that? It's clear one of the common headers, right? Isn't it? Where the hell that is. I could just search define, can't I? Before, and that would obviously work. It's done in a crap load of places because I guess they want to declare it, but alright, so there's no actual implementation, so it doesn't do it. Okay, I learned nothing. That's just useless. Anyway, well, maybe it's useless. Maybe I didn't find it. Right. So yeah, local thread index, which I've got to figure out which one that is. So it's the index within the group. All these damn names. Everyone has their own names, including myself. These things, and they're just confusing if you get them wrong. Group ID, so that's the, okay, so I know which ones it's talking about. So SPD downsample. So we should actually pass in the bundle constants or dereference of that. There was a bug in my compiler at some point, but I think I fixed that. So the first one is the work group. Just put the SPD PC in there. So once the work group, so that's two-dimensional, so that would be SV group index XY, SV local index dot X. So that would be the one that goes 0 to 255 inclusively, right? MIPS, how many MIPS we got? Well, that's actually in the bundle constants, so I don't think we need to pass that in. Right, so where's that downsample? Right, so MIPS, it calls the MIPS function, work groups. Right, and there's the offset. So we could keep that support. Interesting. It's all over the damn place. So number of work groups. And then offset. Where's... Oh, the offset is a slice. Right. Is that what they mean by this? No, because it's two-dimensional. So what am I reading where... Is that an old version? Because they said they added a way to offset the downsample or whatever and do a sub section of the texture, which was interesting. Oh, that's pretty... Maybe it's quite useful actually. If you have like a... an atlas, right? You could just downsample a sub portion of it. Right, you have many textures on a texture. That could be quite useful. So yeah, where's that? Why is it just so all over the place? Oh, sorry, I meant to search for the other one, wasn't it? Yeah, so there's actually, oh, it is. Ooh, I see. Oh yeah, all they did is do plus. All they did is do plus offset. Right, I remember I deleted that function. Right, so it's actually not rocket science to add support for such a thing. Cool. So group Z. All right, gotcha. So in terms of the next parameter, which would be the number of MIPS, we could probably get rid of that one, and that's in the bundled constants, so we can just get rid of that like that. Number of work groups. So that was passed up. Right. It's interesting. Right, so I guess we need that as well, work groups count. So we'll go ahead and look at humming. Better. My PC is resting up against the desk. So it's making like a humming noise. Yep. Yeah. It's very true. So number of work groups and then slice. So slice would be sv dot dispatch group index dot z. Nice. So right, so it's number of work groups and that MIPS. Whenever we see MIPS on non-work groups, we've got to replace that. We're not passing those around anymore. Maybe Yeah, that would be bc dot workgroups count. Neat. Yeah, we'll still leave that there. All right, let's get rid of this. These comments. Right. Okay, that's good. It wasn't used anywhere, so we'll look for MIPS. Hey Temvar, how you doing? How's it going, sir? How have you been? Right, so number of MIPS. We'll get rid of that one from there. Just got to be careful. But so that'd be bc.mips count. Same from here as well. Right, so that shouldn't get passed in there anymore. Wait, we shouldn't be passing these in. Neat. Cool. So what we need to be doing is actually, for all of these, I think, passing down the constants. Something like that. So that function there is actually not declared as part of the single pass downsampler. It's like a generalized one. So we've got to find out where that's declared. Yeah, there's actually quite a lot of header files that have got stuff in. Was a remap for wave reduction. No one learnt from single header libraries. Oh, life would be so much easier. Right. Common half. This ain't about the half. Right. So this is one, for crying out loud. For remapping 64 times 1 to 8x8 remapping, which is necessary for 2D wave reductions. Interesting. So I think I got this. Is this? Yes, it's the Morton curve. No, it isn't a Morton curve. But it's still kind of... Oh, it is a Morton curve. Just across the different axes. Beautiful. I've already got one of those. So basically, rather than going across, let's just go back there. Rather than going 0, 1, 2, 3, 4, 5, 6, so it bundles them up into 2x2 quads, like a pixel shader would. So every 4 indices are always next to each other in a 2x2. So they've done it with this sort of thing, right? I got my own. I call it the Morton curve. You know, I don't know what I call it. Let's go into graphics shaders. So over will look for 8x8. Dispatch index Morton swizzle 8x8. So you pass in the dispatch group index and the local index. Oh, maybe I should just do a Morton 2D from 32-bit because that's what it wants to do. Yeah, because it's square. That should work. Well, if it doesn't work, then this is one of the things that we'll look at and be like, yeah, it's probably this. So that should do it. It converts a 1D index into a 2D coordinate. Pretty powerful stuff. So, right. And we keep going. So we're passing in our bundle constants, so that's just like push constants. But yeah, those get passed into a function in this language, so this is what we have to do for the good of the code. So we'll just pass them down because we need it every single time we do a sample or a store. Hey, Ray March. No, that doesn't count as one in my book. Why not? What's the true Morton? How are you doing? Yeah, so basically I'm doing a occlusion culling. So I did a depth pre-pass and I've got a half resolution, very quick and dirty one where it's got a few errors, but it's faster. And basically, now I need to downsample it, but I've written downsamplers in the past, and you could do I've got a downsample to every single MIP level within a full MIP chain. And you could do 12 passes, or you could do it all in a single pass if you use a single pass downsampler algorithm. AMD's already got one, it's MIT licensed, so I'm porting it over. It's great, it's there and it's open source, that's cool. But it's like scattered across that many files. So it's a bit of a headache, but we're getting there. I don't know how much I want to clean this code up, to be honest. I might just want to get it to work and just forget about it. But as long as the interface for when I sort of pass that, include the header is all good, that's probably all I care about. So I just want to be able to basically say, hey, I want to generate a new specific downsampler for downsampling a texture format of float 32. Every time I get a 2x2 set of pixels, I want to take the max operation. And another thing might be, we might have custom loading code or custom storing code. It's features like that I think we want to add to it. And then, yeah, it'll be super awesome and flexible, and we can just code generate those. Will the only issues is we're code generating them and that's more code to compile, and that means longer compile times potentially, and also boot up times because the pipelines will have to compile. And this single pass downsampler does lots of recursiveness, shall we say. It does this. There's so much like stuff that's inlined, it's insane in this shader. So it's going to be expensive to compile. Can I show it again? Not sure what you mean, which one? The curve. Oh, the one that AMD said, this one. Or it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Wait, I misdid that. I didn't do that right. I'm getting confused. Oh yeah, and then they go down here. Yeah. That's more, isn't it? Z. Z. You got your little micro Zs. You got more of a macro Z. Right? Yeah, no. A small Z curve. Hey, Peria. Hey, sorry, Peria. Peri. Easy to say. How are you doing, sir? Welcome back. I need to revise your name every time you pop in and say hey. Has it got the Ray March approval of being Z curve? Right, so does the first 6 MIPS. So I'm interested in like how it stores them. Right, so pass all this through, it seems legit. Oh, interesting, we're passing in a MIP. Did I delete? I didn't delete that because I didn't say MIPS. Right, good. So this needs the bundle constants passed in, which we do pass it in. And these will need the BCs passed. Oh, and they do a store, excellent, after they do a reduce. What? Okay, what do you mean? Can you please explain? Because I thought Morton Z curve was just the fact that it had the Zs. Like, how can it not be Morton? Draw an image right now. Excellent. Thank you very much. Ultimate Sin. Sorry, it's Ultra. Nowadays, my eyesight from here is like, I don't know. I'm getting old. Let's call it Ultra for now. Hey, Ultra, welcome back, sir. It's downsampler of what into what? Well, generally, when you want to take a source image, let's say 4K, and downsample it to 1 pixel, and you want to keep all of the MIP levels in between there. So the AMD single pass downsampler, I'll drop a link to it here. It's a way to do it all in a single pass and generate a full MIP chain and you do this all of the time. So it's good to have an optimized version in your toolbox. I think in OpenGL you could just call a function called generate MIP levels or MIP maps, and then it would just like do it all for you. But the times of old are not here, and now you have to implement it all yourself. So you can either do that or just use this. See, I don't really use a lot of dependencies, in my code. Typically I would write something like this myself, but there's times where you just gotta there's times where you just have to, it's kind of like I'm making it a single header, but it's MIT licensed and I can make it a single header, so I'm using it. But I wish they made it a single header, I can tell you that. I'm just passing through my bundle constants so everything can have access to textures because they are not global variables. This one is a bit of a BC. And then we can try and sort of design how we want the interface to be to templatize it, if that is a word. Which sounds scary and things that I typically don't do, but this is the way for this thing. All right, so MIP 1 is next. And you take that, pass that through. So all looks pretty legit still. Every time we sample an image, we need to pass in the constants because it's got the array of textures in it. And these textures, in the stores, What's a V0 and a V1? Huh. Out value. Oh no, okay. I see what's going on. Right, ignore me. Array of on the value out. Right, so reduce quad, that's gonna need constant pass thing, because it's going to do some texture sampling. So if you see just in this function alone, you've got these which end up doing basically four loads, and then this does the reduce there. Oh, I forgot about it. And then that does another four loads. This does the store each, right? Another four loads. There's already 16 loads there and 4 stores. Then you go into here and this does, guess what? Another. Oh, that doesn't do some loads. That's all right. And then this does a bunch of stores. So there's so much code being inlined, it's just ridiculous. So it's going to be expensive. Right. So we need to pass this through now. Nearly there. That's just reduce. Right. No, that's using the intermediate. That's actually loading it. Excellent. So these will need your good old BCs. Nearly there. Rightio. All good. Now, so this is the edited AMD source code where I've just deleted a whole bunch of stuff and changed it out for the HCC equivalents. And up here is the stuff that they put in separate HLSL and GLSL shaders where they're defined specifically for those platforms to how they're going to load the MIPS, because the textures are passed in differently, right? Like they're passed in via different, like, are they descriptor sets, or are they, the user can basically do whatever they want with these in binderless, like we are. So we pass in these sort of bundle constants, and our textures are all in there because it's binderless. And yay, binderless. So yeah, when we want to declare a custom downsample pass, let's write the things that we want to be configurable every time we include this header file. So we would like one to be able to change or change. Oh, they're all going to start with the word change. So let's just say configurable properties. So the first one is the texture format. So this thing here, format 32 float. Boom. The other one is the music. No, not configurable with music. We always stick with Stone Rebel. So 2 is configurable. Well, it's not even properties. Stuff. How do you load? Like, so if I load from a texture, because it's a custom format, maybe I've packed it down into a 16-bit integer format. That I might want to turn back into floating point somehow. So what I would need is some kind of custom load function. So because I have a custom load function, I also need a custom store function. So we might as well just make that a single one. And then the third would be, we also want to be able to change how we do the reduce. So when you take a 2x2 set of pixels, how do we when we do the downsample into a single pixel from a 2x2, how do we do that? So there is some simple ones here like min, max, and this is like an average. But what happens if you could do something more specific to your needs that is different to this? So we could, I guess, just have a function, but have these generalized, I guess, right? Yeah. So you can just call these functions, or you can do your own one, which would be pretty neat. All right, let's take a gander at Raymarch's true definition of Morn. So there you go. Morn is Zs arranged as Zs, arranged as Zs. But that one isn't. Yeah, it is, isn't it? Yeah. Yeah, but all right. So yeah, this has just got the XY the wrong way around, right? Isn't it? Oh no, it isn't, is it? I see now. Right. Yeah, because huh. Yeah, I see now. Interesting. Yeah, so their second tier one is not actually arranged. Well, it's arranged in the Z, which is where the XY is the other way around. Yeah. I see. And then the third one, the third tier is going right like that. Yeah. So that's strange. But anyway, the code that I've written doesn't do that. It does it. It keeps the same Z orientation. That's a bit weird though. Maybe the person who wrote the maths was just like, I don't know. Could have. There's examples that do it properly. Right. So let's have different versions of this. This will be reduce min, and this will be reduce max, and this will be reduce average. Mean is the mean, the meanest average of them all. So that is great. And then the user will have to just declare. So I think the user would need to declare, let's get these prototypes. Are they ready? That function. They would also have to declare this function. Right, or I guess we could provide an example. We could provide examples, that would kind of be nice. Yeah, but if they do it at the top, so that means that single pass downsampler min and stuff like that, those might have to be declared in different places. And also, what is this? Oh, wait a minute. Yeah, I guess it's got to do an add. I have no other way of doing it. Nice. Then it's got to do a malus to scale it down. Right, so these will actually be declared somewhere else, so we can make those configurable. So maybe, yeah, so load source image and load will probably need to be. See, I wonder where that inverse whatever was used. They had that in DirectX 12 one. Yeah, we'll look around for that after. Right. So yeah, I think we'll need to put these in a good place. So let's take these out. And, you know, we won't do that. You know, I don't really use this syntax. So we'll just do reduce for mean of that. That's all we'll call it. Reduce for max min. So we'll right. Yeah, we'll sort that out in a bit. Neat. Yeah, so they would declare, and the example would be you either have a choice of returning reduce, or you have your own custom one, right? I don't know what the code does. Maybe it deals with oddities of subgroup sizes, or it's just taking an integer which is bound between 0 and 63. And that's all it's doing, so I don't know why. Yeah, they just threw it in there just to be exciting. Just to troll people, maybe, and get people fighting over what is true Morton. No, it's pronounced GIF. Yeah, one uprising. Hilbert guy. Oh yeah, I remember. It's the European one. Yeah, I should already be calling it Hilbert as well. Yeah, so you have a choice of those, for instance. Pick one. Then the load. Let's just say right it is a MIP. Right, and then a store as well. Neat. Cool. And then the store. Let's nick that. Oh, these things are horrible as well. I shouldn't call it text and pics. Let's call it like coordinate. Slice right, and out value. Well, I'll just call it value. Make it a little bit nicer. Alright, typically though, the way I do it is that the store and load are basically the same except for the value goes in the end. Which means I've got to adjust all the code. It does that. Right, so that's pretty decent. Yeah, so these are the user-defined ones. And then because you're changing the formats, yeah, so they have to declare these custom functions, but so they would have to declare maybe the custom functions and then pass in them. Or maybe they're just macros. maybe they are macros. And then that way we don't have to care about them, the names overlapping too much. That would be interesting. Yeah, so let's move these out. Let's move them to more of like a common place. So those are going to go to something like graphics. Well, I can't go to something like graphics because... Oh, I could go to core.share. Core share. I don't know. I already got a place for these things. So I might have one like image operations, but all image operations are just gonna be on the GPU anyway. Let's stick in GPU shader.h. So stick it down there, and then we'll like find like some like header thing that we can take. So we'll call that image operations or whatever. Find a better home for it later if we find out. Tabs of the way. So image operations. Right. So that's just gonna be generally available now, which is great. So the European one was, oh right, Leby's. Oh. I try and pronounce this name. Leby Sigil. Leby Sigil. Siggy. Leby Siggy. Something like that. I don't know. Probably butchering it. So Leby Siggy is usually ends of ends of ends. All right. Okay, so oh yeah, Hilbert's the other one. I know what you mean. It's the yeah. Or Hilbert curve. Yeah, it's this one. Look at that. It's like a puzzle piece. Doesn't it look nice? Like a jigsaw piece. All right, hopefully my ears don't get blown off. Lebec. Right. Probably French, isn't it? Or is it German? No, it's German. Yeah. The information... I don't know. Pronouncing that. Yeah, it's definitely German. Looks very recognizable. Definitely went kind of French with that German accent. Look at that. Isn't this one more expensive to compute though, isn't it? So anything that's kind of error prone with this is they have to do MIP +1, right? In the user-defined code when you're just getting the MIP passed in. So it's a little bit weird. Maybe we can change all the implementations that do a store. Change those. So let's delete these now. Oh yeah, and that loads source image. That needs to be removed as well. We'll sort it. Yeah. So MIP plus 1. Oh yeah, then we changed it as well. So the MIP was right. Right, so the final out value goes at the end. And the MIP, which is this guy, plus 1. Bananas. Oh, why are these things so different in order? Why? Right, let's make it all consistent. Slice. Let's do it all the way. Yes, it stores the 4 pixels that get reduced. Right. Cool. And then there's another store, and it's all mumboed, jumboed all the way up. So, and the MIP goes there, so that'll be 2 now to add the 1. Oh. Could have already just did multi-cursor because this is the way. Nice. Next. So I've got to do MIP plus 1 here. Oh, it's just such a banana. Base MIP. What is base MIP plus 1? Right, so these could actually then be plus 1, then 2, then 3, then 4. And then I have to change it in the other place. So if we go back to here. Right, gotta change the order of these things. So V. Right, so slice. MIP V. That's what it needs to be. Good. And let's do the other reorder. Slice MIP V. And slice MIP V again. Oh. Amazing. Yeah, but you think Hilbert is better in locality, right? Right, because Hilbert has bigger. Sorry, yeah, Hilbert doesn't have the big jumps. Yeah, especially as you get more and more tiered. Hey, pan spinning. How's it going? Get back to that. So if you did it in a more macro way. Oh no, you wouldn't. Right. Yeah, there is no big jumps, is there, basically? Well, yeah, I guess so. That is true. I was thinking what happened if you have a zoomed out version, but yeah. Do it in 3D as well? Ooh. Hey VD. Yeah, I've always had the standing desk, but I've never used it because my knees don't usually like it that much. But when I walk, it typically, well, I can walk for ages typically, right? I can't just stand still on my knees. So I'm trying to like move about a bit while I'm standing still. But I've also got a treadmill now. So I start work tomorrow actually. And yeah. So the only problem is I can't use my treadmill tomorrow because I haven't got, when I stand on it, I'll be like 4 inches above ground. So my desk doesn't go up 4 more inches. So what I need to do is I've got this little table to come and rest my keyboard on, and it goes up by 4 inches. So my wrists and everything will be nicely supported, which is great. Yeah, I'm looking forward to that. So I have a treadmill, so I'll just be walking for a lot of the day. Then I can bring the desk down and sit down, have a relax. But yeah, standing seems pretty good. I know though that if you do stand all day, there are downsides to that. So you need to basically like switch between them and throughout the day. Yeah, I do feel a lot better standing up here, just posture wise, and yeah, on my back definitely as well. Everything just feels better. Just the knees is the only problem. It's got to be careful about. Also too much sort of weight on them for a long time. But how's it going, video? How you been? So this is the value. I want the MIP. So I need to add 1. So that'll be set, actually MIP 7. So we're doing that, but the V is different, basically. Nice. Right, so what other stores we've got in place? Alright, so that's an 8. So that's interesting. Alright, so we did add 1 to these, but then I didn't. Oh, that's good, that's good. Wait a minute. Right, but if I change that... Oh crap, did I bugger it up? No, because MIP is not being used by anything else, but let's just double check. It's not being used for the loads, is it? Yeah, because it'll just do the load. Just used for the store. Alright, so nearly there. Any more stores in place? So we'll look out for. I think that's it. Right, so next for August. Legit. Very good. So the other one we got to change is the load. Single pass downsampler load and load source image. Actually, we don't have to change this. We could say load. We can call this one load MIP 0, load MIP 6, and just change. And that will call SPD load BC. For crying out loud, you had the IntelliSense and you got rid of it. Coordinate. Oh, for crying out loud, these names. Slice, and the MIP will be 0. Nice. So now it's be MIP 6. Nice. So that way we can have his user-defined functions and things would be amazing. So we just got to change that load source image to be in load MIP 0. Cool. And when we see a load, SPD load, we just change that to be these ones. SPD load MIP6. Cool, so that's the user-defined load. Beautiful. Right, we're getting close now. So now what we want to figure out how do we do is the user declares these, but also re-includes the same header file, which will change this thing, right? So we'll have a hash define, for crying out loud, define SPD texture format 32 float. So this will just go in here like this. Now the thing we want to be careful about is this is what I need to do there, and voila. Well, actually, we could just make them U32s here, and then the user goes, all right then, because we can just cast it from an integer into a texture. So you say format float Beautiful. See, the intelligence is a bit busted, but there we go. So this will be the write only. And then we don't have to do a +1 anymore. We actually added ones anyway. Nice. Oh, it does an implicit cast, doesn't it? Yeah, we support implicit cast at the moment. Bit dangerous. There we go. They're from Brazil. This is C. Yes, this is C. I've got a custom C compiler for shaders, so we get to program shader code in a subset of C, because, you know, GPU vendors like to hold all the nice things from us and don't give us proper access to the GPU, so we can't really get full C on there. So yeah, there are some things which are understandable, but other things are a bit questionable. It would be good to have access to that raw assembly, you know, and run it through Vulkan. Pretty good. I've been working on some C++ projects and got normal maps working. Nice, amazing. And for a Java project, I've made a simple server that sends player position to other players. Awesome. Awesome. Good to see. Yeah, do that. Rightio. So now the problem is when this doesn't have to be a thing anymore, which is just amazing. This have to declare these functions and voila. Well, or do they? How do we re-include the same header file without getting collisions? So these here could probably be declared because they're going to be kind of the same. So the ones which do not have to be redeclared because they basically don't do another load. What crap happened here on my phone? Why did you make noise? Oh, I got a text, maybe? That's a weird ass noise. Well, so these can just be declared in some general header somewhere, which would be called. So with this increase counter, right, all of this too, the loads cannot, because the loads will be specific for this include, right? So that this will be a different load call that we'll have to do. We have to decorate it. It has to be like have a different suffix or something. Load it intermediate though can be shared. Pretty nice. So this could probably go. Got to find a place for it. We could just stick it in GPU shared, but it's not really available in. I might make another damn header file. I hate making files. It's annoying. We could have shaders.h now, where it's only for shader code. Let's just do it. Let's just bite the bullet. And future me is going to be like, past Henry, what did you do? Made another file. I hate this. I hate this. I hate this. Oh, got to pluralize it. So just dump in there for now. So graphic shaders. .h. What have I done? See, I've done some of that stuff in the shared one, to be honest. Shared between CPU and GPU, right? No, the shared internal. It's another point of internal public. But there was one, yeah, the parallel sort, right. You know what? Let's delete that file. Stick it in. AMD single pass. Downsampler, we'll just chuck it in there, it'll be proper nice. All of this stuff reusable. Between the thing that compiles out, just yeah, because it's static. It's all right. I might have to say if. Let's just do that just in case. It's not really though, because that is. No, I'll do for now. All right, it's better. So, is there anything else that we don't have to specifically like paste something on the end of the function name or manually inline everything? This here we could just get rid of that, right? That was only added because it's a thing they do in the source code or the Fidelity FX SDK source code, because they share it, they HSL and a GSL implementation, so this could just be replaced with our memory barrier. Dispatch group. So let's go over all of those and get rid of that. So that's one less function. This one is saying exit. Get rid of this crap here. I guess we'll leave that in there. So this as well doesn't do a load. Right, and this reduce here. Oh no, okay, wait, let's just go back to this one. This one doesn't do a load. So that means we can actually take this one out and stick it here with these guys. Which be quite nice. Comments. Right, so which ones need... So this one does a reduce for. This will be a user-defined function. So that means that this will need a name, a very specific name that we paste on the end. So I think these will all be macros. The only issue is this one here. It's a bit of a bugger, isn't it? You know, this, let's make declaring these easy as pie, because pie is nice. And this doesn't look nice at the moment. So coord will just be 3-dimensional as when it gets passed in. So you don't have to do this crap. You just say coord, done. So this could be made into a nice macro, I think. No, but they might want to make it a function. Anyway, let's make it as nice as possible. So when we declare these, it's just easy. So SPD, load, and store. You know, these are a bit ugly. That's okay. They're inside. Right. Oh, for crying out loud. Same for these ones here, yeah? Right, it's the store, SPD store. When that gets called, sure. So bite the bullet. Right. You know what, let's not change the source code. How about we just have one called store at MIP. I hate doing this, but I can't be asked to change all the source code. Oh, shoot. And it just calls store and yeah. Right, that'll do. So yeah, we'll find, store. Nice. Right. This has got better now. Okay, so any other functions which are not going to need to be, which are kind of, so this one here, reduce quad. Let's get rid of that comment. This one just does a reduce 4. Oh no, but it's a custom reduce, isn't it? Right, okay, so that uses a custom function. And all use custom functions, all use custom, yeah. So from here on out, we need to probably append something on the end of the function names, which is going to suck, but this is the way. So nightmares of descriptor sets, not really, because if you use you don't need to use descriptor sets much if you have used the bindless descriptors, right? You just make 2 descriptor sets with massive arrays and just use those. Or not, I don't know, as big as you need the arrays to be. Bindless is the way. Yeah, there isn't really a good abstraction. I've tried it a few times. I've tried some sort of copy and write kind of method. I've tried so many. The one for SDL, they have an interesting one, I think. Yeah, but it's just weird. You're like tiers of things and the allocator and managing those and horrible. Disgusting. So I'm glad we can move past that now. So the user's going to declare those 4, and then it'll probably declare some kind of suffix or whatever. SPD. Call it suffix, just call it something like that. Nice and short. If it's too long, the source code becomes even more unreadable. So we'll say, let's say it's the format 32 float max, right? And that will get put on the end of every function. So the issue is if the user's declared these as functions, right? Maybe we need to declare some kind of like SPD function, right? Name. Oh, my laptop died. Let's get the charger in there. No. Get chat back up. Yeah, so we need to pass in the, probably not pass in the suffix, just yeah, just do it automatically. So SPD suffix with name, something like that, yeah. Maybe we'll put a nice little underscore in there as well. Cool. So this will so that means the user can just declare their own load function. Like that. Store, reduce. And then they will include this header there. Cool. So this here has to go into that shared header file. Wrong one. Right, this is coming together now. We're getting close. And we've just got to do all the compile errors. This is going to be quite powerful. So you can just declare however you want to load it and unpack it, and then however you want to store it. You know, pack it and store it basically. However you want to do this. So I think we can, there's no arrow code anymore. Let's just, yeah, let's leave the arrow code in there, right? Okay. So we'll do another header where we just go example usage example if 0. So basically don't enable this, please. Right, so we say what is configurable. So you have a configurable so I can just write and say something along the lines of to declare a custom downsampler or we could say each, or you know, not all downsample or we say something along the lines of like every time you want to downsample, every time you need a downsampler, the texture format reduce operation, and sort of like packing, unpacking code. Will probably be different depending on the algorithm it is used for. This header file is designed to solve that problem by allowing you to code generate that specific code without too much extra work. Okay. So I could write some comments describing the code below, but equally I think the code kind of just describes itself, right? You know, can write maybe a comment here. Hey Downsy, how's it going? Oh look, we get the green Santa from... Get the green screen from Santa. What? They got a green screen from Santa. No, I've had a green... I've had a green screen for a while actually, but... So I'm using the standing... Well, I'm using my standing desk, but... The issue is... It's built for me... Well, it's currently positioned for me sitting down. So it's currently horizontally laid out. So I'm going to change around to portrait. And so it'll just be directly behind me, and that should hopefully be good enough. So I can do streaming standing up or sitting down. Yeah, Christmas was good. Just, spent time with family and ate lots of food. We actually hosted Christmas. So, I was a bit merry on Christmas Day. I had a lot of Baileys, and what else did I have? I think I had some rum as well, spiced rum, as you do. Ate lots of good food. And... yeah, just saw family, had a good time, played some games and things like, in real life games. What else did we do? Yeah, the New Year, just went to church, just lots of praying and stuff, praying for the new year. And I was so tired that day. I was tired at 6, but to be honest, when I got to church, I was actually kind of really awake. It's very weird. Can't explain it. But what else did we do? Yeah, just chilling. I've actually just been thinking about just sort of like, I've not been really programming too much over the time off, as I typically would. So I've just been thinking about life and the family and things I want to do for the future, and, like overloading my wife with that. My problem solving brain was just like, oh, since I'm not programming, let's just solve problems with our life and just go all in. So it was just kind of on full blast. But it was cool. I thought a lot about the future and things. But yeah, so it's been nice. But yeah, how about you? How's your New Year's and Christmas been? So we can just say this. This macro makes all the functions uniquely named. So yeah, make a unique suffix such that all SPDFN functions will be uniquely named, right? And then you do this. It says a custom load function, custom store function, do whatever the hell you want in it. And then custom reduce, you have a choice between any of those. We can just say different versions. Neat. And then you just do your include AMD Downsampler, and this is where the magic happens. And voila. So I guess let's take this and let's give it a go, see what happens. Oh wait, we haven't done this SPDFN around all of the function calls or the definitions. So let's quickly go ahead and do that. Yeah, so I want to say up here, do a thing where we go, oh, if not defined, this thing, then there's an error, please define SPD suffix, follow the usage example above. Yeah, it's great. Cool. And this is a store. I keep trying to write the word storage when I write store for some reason. Bizarre. Hey, Cranston. How's it going? Quiet Christmas at home. My brother came for lunch first. No other family anymore. Oh man, that's sad. But yeah, at least you got your brother still. New Year has never been a big thing for me. I prefer eating snacks and watching films at home. Amazing. Finalizing itinerary for Japan trip. Oh, awesome. End of March. Great. Yeah, me and my wife haven't actually been to Asia yet. We probably would want to go to Japan or Korea or something. You know, sounds like a lot of fun. Yeah, it's awesome. Very cool. Yeah, we're looking. Yeah, we've got other things we want to save for and spend in the meantime. Yeah, I think one of our next bigger holidays will probably be somewhere in Asia or maybe the States. Because we haven't been when we've been together on our honeymoon to Zimbabwe, which was very, very nice. Oh yeah, well, the falls was really good. The capsule's a little bit weird and dodgy though. Rightio, so we just got to go ahead and find every time we do like an SPD whatever. Right, I'm just going to do this. So if we say find all of those, full circle, great. So we SPD function the macro preprocessor. Right, these intermediate ones, these are okay. Yeah, those are okay. It's just because they don't actually load from the custom functions. They load from like thread group memory, and that's stored in some extra. Those don't need to be code generated. They stay consistent, which is super nice. Oh no, this one because it's a reduce. Hang on a minute. There's no reduce intermediate. Did I delete something? Right, to the reference source code. Reduce immediate. it's in the other source code. That one's in, right, to search for it. Sorry, intermediate. Rightio. Alright, it's called here. Oh, that's the LDS version. Right, we deleted all that code, so maybe then. So we do it with the wave operations one. Yeah, okay, good. So we can just delete that function. Very nice. Alright, SPD function. Nice. Next one. So this technically doesn't have to exist as a function, but I guess we'll just do it anyway. It's only called once, right? But there you go. Oh. Nearly there. And we'll be able to give it a nice go. Right, I think that's all of them. So we've wrapped them all this macro, so it appends a suffix every time we include the header and makes a nice long function name so it's different and unique. And then we can include it all into the same C source code for shaders. And that all gets, oh wait, this one needs to do it as well. Yeah, SPD, nice. So then we can just include and have hyper-specialized ones for whatever use case we want. Beautiful. So we're going to take this and we're going to go over to graphics shaders. And we're going to find where we do some occlusion stuff. Occlusion, I don't know. Well, right, occlusion ray tracer. Well, there we go. I don't know. We could have a place where all the downsamplers live, right? But so this could probably be organized a bit better, to be honest. Yeah, why don't we make a section and call it occlusion? So it's just called shaders. Yeah, okay. So we'll stuff that's specific for occlusion. So we'll find that occlusion ray tracer. So there's the custom downsampler. This is where the magic happens. Rightio. So this one is going to be called... I can just call that occlusion buffer. Nice. So for the occlusion buffer, it's going to be a float 32. We're going to just load. Maybe we'll do some actual packing to 16-bit ints at some point. You know, some fixed point thing. But yeah, so we'll keep this specifically for the occlusion. Then I think what we want to do is do a max. Is that right? So if we've got... Yeah, we'll need to take the furthest away one. So we just use the reduce max part of it. Cool, so if we get 2x2 set pixels, we take the maximum of those depths and then return those. Yeah. So the thing is about it though, is that it treats it as like 4, you know, maybe... Yeah, hopefully the compiler can optimize this, right? We only want to store a single value back out. So maybe, you know, it all gets in line. So it should have enough visibility to know we're only using, actually using storing out one of the coordinates maybe. The rest of the logic isn't dependent on that, so it might get rid of all of the other ops maybe. That'd be cool. So this reduce, then technically you only need it would say dot x. Oh no, can't do that. Yeah. Alright, just leave it like that. Cool. Alright. Okay, I'm just gonna go get a nice drink. Maybe I'll get another tea actually, just, you know, be nice. And then we're gonna try and compile this. See how many compilers we get, correct those, and then test it out. Hopefully it works. And we should see our occlusion buffer have a full MIP chain from our sort of so it'd be a depth pre-pass that gets fully downsampled to a 1x1. So be able to inspect all of that, which would be pretty cool. So yeah, I'll be back in maybe 5 minutes. So yeah, enjoy the tunes while I'm gone. Hopefully the tunes are still going. No, they are. Alright, welcome back everyone, how's it going? Welcome, welcome. Just got myself a nice peppermint tea. Cool. Alright. Let's get these back on. So something that I did forget to do is that we haven't written any of the CPU code that actually dispatches this generated downsampler. So then you'd call later you can use, so yeah, we've got to make a nice easy to use function that basically dispatches the downsample. So we'll get to that, but let's just make sure the shader code compiles. So if we go to run the game, here we go. So already in the shared header it's like the brackets are wrong. That's probably could have been where all those, I don't know. Right, let's keep going with that. Definitely my compiler, isn't it? My compiler done. Has my compiler got a pre-processor bug? I think it does. Damn it, I got a pre-processor bug in my compiler. No. Right, let's just double check it is that. So in the concat buffer it's got that in there. So it hasn't eliminated all of the... So say if I got rid of that, does it work? Right, interesting. So if I was to put double underscore there, does it work? Can I do two pastes, or is it? Let's put something else in there. Right, so the code that picks up there's the concatenation. I'm not able to do multiple concats in the same. Bizarre. Should we fix that now or fix that later? We can always just take a quick look. Seems to be time. So let's open up a new tab and hop into HCC. That'll be in. So we do the preprocessor stuff here. There's a concat. Copy expand macro. So you go over all your macro, all your tokens. Right, does it continue? Right, so after you go through here, what are you doing? if it's string and the last token is a string, merge the two strings together. If not, push on so that's stringify. My mistake. Concat before and after. But it's running concat. And then the bug happens within here, guaranteed, doesn't it? So it'll come across the preprocessor concatenate in the stream. I think. Yeah, so I think there's a while it's trying to hang on a minute. So we get the before tokens and then after. Then we're running in this mode. And then the ATA gen, so the token generator run puts the locations in the token bag, but we don't care about them. Right, is this the error that we're getting in the terminal? Does not combine into a valid token. So we're getting the error, this and that does not combine into a valid token. I guess we can look at the errors. Let's look for where that's emitted. A bit of a better idea. It's emitted here. Before token, after token, interesting. So you would do a so concat. So virtualizer can connect this. Where's after token? Yes, it's hard to know without running a custom version of the compiler on here. What happens? So it might come into this function, process the first lot, then go through here again. There's a source bag as well, isn't there? So do I have the way to get the call stack? I don't think I do. Oh, I can. I can do that. So if I cat the scripts, we can take this lovely line here. GF, like that. And have a nice, so we break on HTC bail where the error happens. Nice. Okay, so we didn't expand. Ooh. Right, so what's interesting is, right, so I wonder how many times we do this. Put a breakpoint there, let's run it again. Four, five, six, seven. Right, 7 times. So we can actually find out. Right, this is good. 1, 2, 3, 4, 5, 6. Perfect. Right, so here, can we figure out? So let's keep going. It then just fails here because right, so the after token is that sort of hash thing. So if we look at the 6th one, 1, 2, 3, 4, 5, 6. No, the 5th one. 5. Copy, expand, macro range. Right, so then that's gonna go. So I think this one's gonna go and do its thing, right? And then it calls run. And then inside run, it's gonna do it inside this pp concat mode. Oh no, it doesn't. Okay. See, I feel like... Okay, so that's going to do a continue. Yeah, I don't know what this is. But I can print out the code, I think. Right, it's just the for each thing. Okay, so if I go here... P code file code. Load underscore underscore, then that. Interesting. So stringify buffer, where did it do the stringify? So this probably does it here. Stringify single or macro. Okay, so what we're doing is we're stringifying the load. And the after token will start with, right, so maybe this right hand side one. How often is that called? Perhaps if it's got its own pasting operations, maybe it just needs to go ahead and No, because right, perhaps we just need to OK tagging on an ident and a right, so these two are OK. So an ident and then an ident will be OK. But then what happens is these two get stitched together, and then it's saying, well, after it was stitched together, that's maybe this check is just wrong. False true after. Right, okay. So the after token I would like to think that's the identifier. So it's adding them into the stringify buffer. Puts that, and then the one after puts in the stringify buffer. Right, then they get combined into a single token basically after this gets called. So, right, inside this function then something, it's returning the wrong token. It's probably an actual bug. Right, okay, so if we find where that's actually declared. Right, so that token it's returning. What's happening with that? +1 parameter. Right, so the before would be name, and then after I think would be this. But that's a parameter, so it will then get resolved into whatever it was. And then stringify single. Right, so we go back to that function. Right, so the fact that it advances the cursor might be problematic. We're probably not looking for it to do that, maybe. But there's a stringify single that happens. I think we are. Alright. Right, so if it's an identifier, it will, okay. But in this case, it's a concat argument or something like that. No, I think we added one. We can just go through the code and that will just tell us what's going on. So let's do that. So we restart 1, 2, 3, 4, 5, 6. Right, so in before, I'm not that interested with before. We know what that does. After, though, we are interested in you. So after, right, it's not parameter. What is it? It is a concat. Right. So because it's the concat, the double token gen will reorder the macro concat that comes before the two. Oh my days, what have I done? So in stringifying, it can put back the order after it is in string form. What have I done? Right. Why did pass me do this? So stringify single. Let's see what that does. It calls the same function again. So it passes the ident. That'd be the left. And side one or something like this. See, I think it's ultimately returning the wrong token. Ultimately returning the wrong token, maybe. So if we look at the location, yeah, right. I think that's the bug in the compiler. So how do we fix it? So we get the token. It's a parameter. If we've got the token, it would be a. Hang on a minute. Right, let's run that one again. Cool. So let's go into this before one, so left hand side. That's going to get you a parameter, right? So it returns the fact that it was a parameter. Or a return token, so it returns the fact that it is an identifier. I think that's what it is. So whatever that is, I think that's identifier, because 0 is like, yeah, good. Cool, so we know that one. So that's in the, right, then we're going to here would be the concat 1. So yeah, that's 11. Go to here again, so 11, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, that's concat. So let's run that again quick and look at the numbers. Right, so here the cursor token index is that number there. A7148, so just remember 148 basically, 148. So let's finish this. Go over to here. Print it again. 149. So it's returning the concatenate anyway. So why does that not fail when we have a different, if I was to do this, why does this not fail? Right? It's an interesting thing, right? Because if we finish this here, the problem is because, right, so yeah, so we'll save the file, right? And run it again. One, two, three, four, five, six. So the token you get there, what's the after token? That should be 11, which is, it's 1. Why is it 1? Because before might have done the processing maybe? Is that processing the next token? Just an ident. Then this one here processes the parameter. What parameter? Oh. Did it just skip over the concat? How did it do that? Alright, so look at that again. So, oh crap. Cursor. Right, 5, 9. Oh crap. Alright, so that one again. Just the right macro expansion. Alright. Alright, 148. Right, so it just expands that into the stringify buffer. Then what is it here? 149. So the token doesn't actually exist at this point. Right, because it must have been, right, something's going on here where there's a step before which generates these. Right, so the thing that generates this sort of like macro concat thing is here, token add. Right, so when we sort of consume these hashes or whatever, right, so this is the only place where it happens. So what ends up happening is the yeah, so it skips the hash altogether and then just right, so I think it reorders the tokens. Yeah, so okay. I think I got an idea of how it works now. So what happens is when you have something like this, it gets reordered in such a way where the hash comes first, with a space in between, such that it can then just stringify the next two things, right, and put them into another buffer, and then voila, right? So when you've got two of them, so imagine if we did it like this, what's going on is it's coming across this hash. So it's going, okay, we'll put this out before, and then put a space there. Nice. And then this would just be left in like that, I think. That hash token will still stay there. So why don't we come across the next? Right, let's just have a quick look. So temp token. What are we popping there? There's a hash. So there's a hash basically, isn't it? Yeah, there's a hash. Pop that token off. Skip it. Add on the concat. Right, then put that token that came before the hash in there. Yeah, so you're basically swapping. So I can put a... All right. So pop. So we're popping off the name here, pop off the pop temp token. Skip that. Push concat token. Push temp token. And then push. Right, so essentially we're just reordering. Reorder. I don't know if this is a problem, the way we do it, we'll see. So reorder A, B as, right, that's what's going on. So, if we do that, we're going to end up so when you come across the next, so let's do an A, B, C, and let's just play around with it. So we have an A, B, and a C, I guess. First of all, it's reordered such that A and B like that, right? Then you've got your C and your C there, yeah? Now you come across this, we want to take that token there and reorder it such that, that, and that, right? So that's what's going on. Okay, I can see. Right, so it's coming across that token, being like, oh, why is this here? I'm expecting a so I guess if we have this case here, crying out loud. Or what I could do is just paste in a I don't know why I did it this way, because I think I don't want to come across it and then already have emitted the token and have to take it out or something, but I'm already doing that here anyway. Maybe we could come across the token, take out the last one. Let's see if we can keep the current approach going, because otherwise maybe it'll be changing too much. But yeah, so it would have stripped. So that's the questionable thing, right? Where's it gone? Good. Right, so this is the thing that's like, why hasn't it stripped? Oh no, it wouldn't have stripped it, right? So yeah, right. So it would have come across the so if we come across another concatenate. Do we just do before again? That was the problem with that. So if the next one is a concat, do before again. And just keep pasting. But the problem... Right, source tokens. See, maybe we could just change it, right? So if it's equal, if you come across this, what will it take to wind back the previous token? All right, let's not do that. Let's keep on with the current approach. So if you take the concatenate and you come across another one of those tokens, so we're advancing this token index anyway. Yeah, so we can just keep processing them. Right, I think I got an idea now. Okay, this is good. We can delete this here, get back to where we were. I think we can solve this problem quite easily. So, you ever got it before, and then if you peek at this next token, you go, oh, it's actually a take that code. If we look at it and be like, well, this is a, then right, so you got the before the hash hash and the after the hash hash, and then sort of like merging. Apply. Yes, it's merging those locations all into one. Okay. Excellent. So this just has to be done in some kind of a loop where we keep going, providing there is a next thing. Yes. So you do your before, and you've got some kind of a loop here, or you say, while there is one more to do, so the thing is you can keep getting a bunch of concatenates that will show up, which is okay. So yeah, I guess you have like a sort of a concat to do count, something like that. So start off as 1, and you just want to say while we have a concat to do. All right, cool. So what we're gonna do is get the bag. What bag is it? The source bag. All right. So in here, I guess we can get the afters. I think that's all right, isn't it? Alright, got to be super careful here, and so these arrows should probably go here like so. Allocate a new location. Alright, seems like that got rid of those compile errors, but we just got to be super careful. Right. So what we're looking at doing is saying, right, what is the current token? If the current token is equal to one of those HTTP tokens of macro concatenate, so the double hash, right, with a space in it, basically. That's what the other one is, with a bit of space. We want to up the concat to do count by 1 and keep going again, right? But also take the increment, the cursor token index by 1. So we skip off of this one. Cool. So then you'll get the after token. The destination, so we've got to be careful here, is equal to before. Well, that should have gone here. And then we do a merge. So we merge apply, so we keep extending it every time we come across a new one. What's this parent location? I think, what's this going to do to parent? Crying out loud. It doesn't do anything with parent, right, good. Or macro, so these go here. Cool. Rightio. Now we check that it's valid to join these two things together. And then we probably... So my question then is like, well, if it's okay to join those two things together, then I guess they must be the same. Yeah, it becomes an ident, isn't it? Yeah, so it sticks to being before or something like that. Can I join minus unequal? The preprocessor is a great can of worms. But yeah, so what does it then become? Is the question. So I think this can get quite... Yeah, maybe this is going to create problems with this. We could probably just keep with it before and that'll probably be okay. I guess solve the other problems later on. Yeah, let's just stick with the before token. Yeah, that should be fine. Right, then afterwards you would have basically made one big old string buffer. Oh, we should decrement the count, that is for sure. Concat count minus equal 1. And voila. So I think that's it. Cool, so we take this new version of the compiler. And we can test it all out in the code base. That was a bit weird. But there we go. So we do a script. It's a release build. Hopefully it all still works. We can run the samples. All right. Right, sample still runs okay. Okay, that's good. Let's take that new compiler. I've got to go on Windows again. Oh no. When I commit this, I've got to go back on Windows and do another one of those builds of that compiler on there. And right, so back to game without an engine, third party, and chuck that in there. Whoop. So if we take a look over in here, let's see if that works. Well, I can run it in the debugger first, isn't it? So running the debugger, we can actually catch it. So if I put a break, well, I can't put a break on bail anymore. What was the line of code? It is here now. So that is, all right, ATA Gen 1567. All right, this is it. So we'll keep going round and around, and we can look at the stringify buffer. Cool, that didn't bail. Excellent. So where's that stringify buffer at? W ATA gen dot ppgen dot stringify buffer. That worked. But it didn't expand this, which is expected because it's got to be passed in. Right, this is good. So that actually pasted that, an underscore, or a couple of underscores, because I had it at that. And then this name here, but, you know, because it's a preprocessor. So I think this is fine. We've just got to change our code here. So all we actually need to do is do this. Put it in an underscore. Wait, we call concat. Oh, C. So this is one of the things they should improve in C. Just an underscore, that's all I want. But yeah. If you try reading the spec for macros, oh my days, good luck. It's a roller coaster. So difficult to understand what they're trying to say. And that's why the MSVC compiler was apparently not C compliant with a preprocessor, but the Clang one was. But it was, when you read it, it's difficult to understand what is actually compliant and what is not. It's something to do with this sort of thing where you pass it in. I think MSVC does, there's something it does without the, they added a flag to make it C compliant. It's just dodgy. Let's try this out. So if we run it, I want to run it in here again because I want to see break source ATA gen 1567, I think it was. Yeah. So let's go down in here. Oh, it's not, is it? Right, we're then going to run until this one here. Wait, was that skip or a run? I have no idea. Right, print out what's in the string buffer. It didn't work. Why didn't it work? Passed it in. Oh no, because I don't know, let's find out. If I run the compiler, we can check the codegen file, and that'll tell us if it did it all right. So it says you run. Okay. Right, let's get the rest of it compiling, and we'll get back to this. So inside the downsampler, the error is on So you telling me that they're never signed anyway? Oh no, okay, so that's a cast, isn't it? Alright, let's give those a go. Right, next one. It's another cast. Are they all just really... I don't know. They're all looking to do some casting things like this. Weird. Right, there's some addition here. I don't know why I'm using signed. They were using signed, but they seem to be casting it. There's no division or anything. And I just cast it back to an unsigned anyway. I don't get it. Right, yeah, it's done. Right, let's not make it signed anymore. Let's make it unsigned. So we can get rid of that stupid signed cast crap. That'll be pretty nice. I did some multiplies and stuff, but yeah, so we actually missed. There might be some reason to do with some of the other languages or something. I don't know. There's no like things that specifically make it being signed be like help anything. Does it just get casted back into U32s anyway? Wait a minute. Cool. Oh crap, I didn't remove that comma. So the closed bracket. Right. Cool, any more of those dot about? Plenty, I guess. Right, so just take that. So this is the same, but there's an 8 instead of a 4. Sorry, there's a 4 instead of an 8. And then this one here is the same, but there's a 2 instead of a 4. So, yeah. Neat. Right, I think we're there on a lot of that silly signed stuff that was going on. See what happens. Right. Use of undeclared identifier graphics global. Right, where's that declared then? Where did I put that in the end? Oh shoot. Oh no. I'll put it at the bottom. Alright, let's move that more towards the top then. Put it here. Cool. Right, what's this one saying here? GPU. Interesting, what GPU needs to be then. That's in GPU shader, isn't it? Right, so GPU shader. Too many files. Cool. What's this one saying? Let's type name, but got identifier. Right, so that's literally not declared yet. So the problem is I'm using the globals before the globals are actually declared. So this AMD stuff, at least this one here, should probably come at the end. Although, can you declare one without the other? I guess you can. Let's try that. Cool. So now we're on to the actual compile errors of those functions there. So it's on the preprocessed stuff okay, apparently. So yeah, that's not... So why doesn't that take in a slice? Functions can't be wrong. Maybe they're wrong. I did change them recently again. Maybe I messed that up. It is a potential. Ah. Right, so it's in shaders.c. So if I use the 2D format 32 float, for instance, that's what it... Right, so let's go back in the HTC source code. See, these are using 3s here, yeah? So there's no reason why these should be using 2s. No, but these are 2D arrays. Oh, yeah, the 2D arrays. Right, of course. So, interesting. Right, so we'll then just say .xy here. But you have a... Nice. Right, so let's make sure we correct that in the example. Nice, give that a go. Right, what's this one saying? Cannot convert float to a float 4, so I guess we just do something like that. Store should be texture. Expect this to end declaration. What declaration are we talking about? I think a function got left open. What function got left open? One of these? This is all F0'd, right? It's just an example, it's just sample code. So reduce quad. Oh, load mip 6 and all that lot. Those should be your SPD. How did I do those? Oh, I missed a few, apparently. Right, so let's get all those. SPD function. Neat. Right, so what was complaining was the reduced quad. So maybe... What's wrong with this? Ah, double open. What a bugger. I thought my compiler would have caught that though. Right, reduce 4. Cool, so, oh, crap. So, SPD function, nice. Rightio. Still more things to do. Yeah, so it's actually put an SPD suffix on there, so I think we've still got a bug in the compiler, but we can, shouldn't be too bad to fix that. Wait a minute. I should get resolved. Is having a macro? Oh, you might have to pass it in a couple of times, isn't it? Yeah, I think this is fine because that doesn't get resolved there. You have to pass it in another time. Crying out loud. Yeah, I see what's going on. But anyway, declared identifier. What do you mean? Reduce 4, right? It's not called reduce 4. We just called it reduce, wasn't it? I think so. So if we get rid of those like that. Oh yeah, we didn't call it SPD reduce. We just called them SP. Oh, so the cursor's nice. Let's just reduce. Like that in it. Neat. Get in there. Right, reduce quad. What's going on with that one? It doesn't need the bundle constants, but we could always make it take it though. But yeah, this one doesn't need. Crying out loud, I went way too far. Let's go most of the way. Nice, give that a go. This one I'm complaining about here. Right, store at MIP. I missed passing in the bundle constants in these guys. Yeah, I've done the sharing code between GLSL and that before. Yeah, when you want to share enums, you have to hash define them, isn't it? Stuff like that. It does kind of work. There's just a few little things which are different, like casting as well. Casting is one where you have to macrotize it as well. If that's even a word. Alright, nearly there. What's this? Oh. How didn't I get that one done? What a silly Silly me. SPD function. What's this complaint about here? Not enough arguments. Right. What's up with 0, 1 then? What did I do? Oh yeah, I got rid of MIP, wasn't it? Why did I get rid of Oh, so MIP's count. Is that really what it is? MIP 0, 1. Where it says the fidelity FX. MIP 0, 1. Did they call it MIPS for passing the MIPS count? That would be a bugger if they did that. So it's the number of MIPS, but they passed in MIP. Yeah, so it's just invalidly named, damn it. Right, so that is not really the MIP, it's the number of MIPS. These people. Right. And it compiles. No, it doesn't. This code is only meant for get out. Hang on a minute. It was in graphics internal, wasn't it? Yeah. Internal shared. So for this one, I would say if. Yeah, this needs to be sorted out properly, but it's not the time for that. And it compiles, look at that. Rightio, we're back up and running. So let's just double check and make sure that we are doing that pasting properly. So the reason why this doesn't work properly is because you actually need another one for the SPD suffix to be evaluated. Right, I know. It's weird, but let's see for you. I think that's right. So it goes through those many and then gets pasted. So, right. If we give that a compile and run, we can then check the metadata. And in the metadata, that will tell us what the function name is. And then if it's not got SPD suffix there and got occlusion buffer, then it's worked. So there is a metadata HCC, what was it, build? Right, it's something in build. Open build shaders metadata. So in here, you would look for downsample, occlusion buffer. It works. So I can paste everything together nicely. Wait a minute. We don't know that for sure. Let's quickly double check it by running it in the debugger. So the compiler and the debugger again. We're going to break on source ATA gen.c 1567 and then hit continue until we reach the right one. I think that's it. And keep going until we hit the string of. Then we can print out the string of 5. There you go, load occlusion buffer. Beautiful. So it's able to paste, can contain multiple things together in one thing, which I thought must have that. But anyway, that's a weird bug. Thought must have been solved by now. But there we go. Right, that's awesome. So, what is next? to do. So the next thing to do is actually try and write the CPU code which will kick off this downsample. So we need to go over to graphics or internal.h, and in here we're going to make a downsample 1. So unfortunately we're going to have to pass in the shader. So graphics downsample, so you pass in the shader, so HTC shader, so whatever the CodeGen shader is that you're using. You then need to pass in that resource ID that you want to downsample. So we could just probably take the full number of MIPS, but maybe you want to, yeah, so you could say texture ID. And then what you want to do is say MIPS, the number of MIPS you want to downsample. You might be able to do some offsets and things, but we can always add those later when we need them. So we could then just say MIPS count equals 0 will be the full MIP chain. Cool, so we find the implementation of slow and direct payload. Slow and direct with payload, and plop that down there like that. And all we're going to do is say, right, if GPU texture, well, it's the thing, isn't it? Can we get a number of MIPS for texture? I think I got that yet. So we're just going to get the resource and then just return the property, right? Could be a better name. Or a more consistent name, shall we say. Alright, and then we, yes, we say, right, if the MIPS count is equal to 0, we're just going to go ahead and say, right, MIPS count is equal to GPU texture MIPS MIP levels count texture ID, and voila, so that's the automation there. Now, we need to get the SPD, single pass downsampler bundle constants. And we're going to initialize those to 0. Then what we're going to do is go over all of the array slices. You might want to know like what base slice or something like that, but for now, yeah, we'll just array layers. Now I'm just going to go over all the array layers. Because, oh, there's only, it's a cube map or not, basically, isn't it? And then we're going to go ahead and initialize bc.texture. Textures to whatever. Wait. No, it's the number of MIPs, isn't it? Oh, I get confused. What's going on? For each MIP, isn't it? Yes. Oh, it's each MIP. Right, excuse me then. We still need that array layers though. For when we do the dispatch. So then with each MIP, we populate it with, so I think there's a way to get the resource index offset. So we offset the ID by 1 basically for every MIP. And then right, so that's those all initialized. Now the MIPS count needs to be set. Then the work groups count also needs to be set. I forget what this is. So something like divided by 64. I think it's the resolution divided by 64. So it has to be a so we don't really have a function to get the resource type. We probably need one of those. Because C++, no way. Hey Shabib, how's it going? Welcome. Yes, I think we need the resource type. We need to be able to get that from, so resource type, doesn't have to be a texture, just turn it on that. Neat. Cool, so with the resource type, we can now do a lovely assertion. To resource type 2D or 2D array. Must be 2D or 2D array. Yeah. Neat. Rightio, so that's good. So number of work groups, I think, right, we can delve into the FidelityFX SDK, but I think it is C++, yeah, so I think it was like num work group. Rightio. Oh, that was included at the top of the file, wasn't it? Right, so you pass in the rec info, so the rectangle that you want to. Nice. These are arrays, aren't they, or something like that? do they ever turn out, basically? And then MIPS is in the y coordinate. Right, okay. Very interesting. All right, how are we getting... Where's the divide by 64? There it is. Yeah, so it's just a divide by 64? No, it's a round up. Yeah, it's just a easy. Right. So yeah, it's just a chord divide round up with so it's the sum where's the texture dims at? So it's the you want to sum. I got to do the divide round up. Yeah, I'll just do it individually. So you do dims.x 64, and then you're going to multiply y as well. Good. It's the number of work groups. Nice. So after that, that's every bit of constant setup. So it's just got to do a dispatch now. So it's a GPU command dispatch the shader with the so it's a divide round up of dims x64. Pretty sure we'll double check it actually. In the Fidelity FX SDK. So in here, where's the dispatch? Create pipelines is saying it. Schedule dispatch. Right, where's the actual dispatch count? Dimensions X, Y, Z. Right. Oh, excuse me. Whoa. Yeah, it's just the divide by 64, isn't it? Of course it is. Noise and the Y. Okay, so that is not showing up. Forget what it is. Of course, it's the bundle constants, right? So you just go the address of the bundle constants, how big are they? And then they get recorded into the command buffer and so that appears to be it all stitched together. Now let's just throw it. Oh wait. We need sync code. Sync read write on texture ID. And wait, we also need to read write on the global resources. So GPU global resources resource ID. So we take this, we find where we do the occlusion ray tracer. So occlusion ray tracer. So render occlusion buffer, right? So this sort of like depth pre-pass. Basically, we get all the models and instances and generate the ellipsoids, tile bin the ellipsoids, and then dispatch the ray tracer to do a depth pre-pass, right? Now we use a specialized downsampler as HCC shader. Downsample. Is there a special downsample? AMD downsample occlusion buffer. Now we throw in the texture, which is occlusion ggfx.occlusion texture ID, and the number of MIPS. Just put 0 so it does it automatically, and hopefully that's everything. What's this complaining about? So this one needs to be a 3D. So 1. Oh, so that's the number of slices, isn't it? So those array slices, array layers as we call it in this one. I just copied the the Vulkan name for it. Offset, what are you? That is MIP. Cool, let's give that a go. Run is cast into U32. Oh, of course. GPU, get the index for that resource ID. Huh. So all I had to do was that plus that, and then easy peasy. Nice. So I think I need to make a function which will automatically generate a bunch of MIPS that come after each other. Sorry, texture views that come after the base. Texture views which view each sub MIP of an overall texture with a bunch of MIPS to follow after. Yeah, so there's the occlusion texture. Right, so seeing some issues here, but it's happening, right? It's running. But when we run it, this gets output onto the MIP 0 for some reason. Right, so it seems to be an off by 1 error. We did sort of change the store code so that it kind of, you had to add 1 explicitly. Sorry, we removed the explicit add 1 from the SPD store function, so the user who's doing the custom storing doesn't have to add 1. But in doing so, I buggered this up to the point where it doesn't actually store it to the right one, apparently. I think at least. So we'll see about that. But we're getting close, right? Things are happening. Let's just take a look. It's at the downsampler code. So, here's the entry point for the compute shader. Calls this downsample thing. It does compute MIP level 0 and 1. So let's look at that one. Apparently there's a phone first. So here's where it does some store MIP thing. Did I? Let's find where it's declared. I think that's okay. Not gonna lie. I do think, because we're passing in 1. So maybe the way I generate the texture views might be wrong. Let's have a look at those quick. So yeah, it is, I think. So this is when we initialize it, we just go over and create a bunch of texture views that point to the first one, because it's got a size of 1 pixel, and it actually gets resized when the screen gets resized. So when we recreate the occlusion buffer, if it's been resized, if the screen or the scene dims has changed since the last frame. So we'll invalidate it, because it gets preserved between the gets preserved. So we can reuse it for the next frame type of thing when we generate the next occlusion buffer, which we'll go over more in the next stream because we'll be finishing it off. But MIP level, base MIP, that should be 1. So hang on a minute. Right, yeah, this is the code that's wrong. Just gotta get to it. I don't know what I've just done. Right, so when we instantiate them, what's wrong there? Well, you only need to start off on 1, right? That's a bit of does that need to exist anymore? Right, so let me get rid of that. All right. Cool. So when we do this, we start off on 1. Because you don't need it for the first one, because the first one automatically just, when you write to it, it only writes to the first MIP in the MIP levels when you use a store from a shader. So you only need these text views for the MIPs that come after the first one. It's just a silly requirement that is just still around for some reason. I have no idea why. There must be some reason. But I can't see why there would be a reason, because you can read from any MIP level. You can do a load from a different MIP level. Or is it a sample? Wait. Yeah, you can sample from any MIP level, but you can't load. It's a bit weird. So maybe there's some things there. What's going on? Yeah, you just do a nearest sampler and you can just do a load that way. Right, so the base MIP level and then yeah, that'll do it. Cool. So I've got to make a function which basically does this automatically, because that's how the downsampler is going to require it to work. So base on the base, which would be occlusion MIP. On that. Cool, let's try that. That should fix it. Oh, nearly there. Cool, so let's go to MIP 1. Looks like a downsample to me. Let's go to MIP 2. Looks like another downsample to me. I thought, no, you bugger, what have you done? That's messed up, isn't it? So what about, obviously MIP 4 is going to be broken as well. Yeah, so MIP 3. So I think I copied I must have copied the code over a bit wrong. Or edited the code and it's just like broken. So MIP 3. Something silly, didn't I? I added the 1. Might be something to do with this. Because I did change this code here. So I guess we take a look at the Fidelity FX one. Alright, MIP _3. Alright, let's see what's going on here. What did I do wrong? So scale by 4, add half x, half y. I changed the order of those because of my I changed the. Yeah, so that was consistent. Seemed alright to me. So it could be how it's loading from the intermediates though. So it could be like because of 2. Add half, it's the same thing. And I didn't change this line at all. What was the MIP level? So basically, like these are MIP levels. So what you do is you have a texture at a certain resolution, and a MIP level is basically another texture that's half the resolution of the one before it, and the next MIP level is the one that's half resolution of the one before that one, and it keeps going until you can have as many as you like until it goes down to 1 by 1 pixel. So this is just a shader which downsamples an image all the way down to 1 by 1, or as far as you like, basically, in a single pass. That's pretty cool, pretty clever. And yeah, I've just ported it a little wrong. Alright, this is the AMD's one. Let's change it where it's a +1 +2. Because of the way the storing was working. So because the store would do a +1 in the user code, it was really weird the way they did it, so I decided to change it. So if the MIPS count, so base MIPS +1. Well, yeah, that was fine because it's not. Wait a minute, it's just, so base MIP will be 0 at this point, I think. So next 4 would be 2. 2 + 1 will be 3. Yeah. Good, so that doesn't need to change. Let's add a 1 here. So it looks very sort of like, if we run the code, when you get to 3, so 2's alright, yeah? Ignore the flickering, that's just another bug. 3 though. So you get these weird like triangular things. That's sort of appearing, but it's not consistent, it's also flickering. So weird. So it could be just to do with what's in the LDS memory, right? From the previous 2. 1, but then like shuffle barrier. Yeah, that's fine. Could it be the number of dispatches or something like this? Just double check it's all right. So XY reduce quad. Scale, add. Right, I think there's some inactive lanes. Ah, that must mean my swizzle might be a bit off. I think there's some inactive lanes. So I think we've got to use their swizzle. Yes, that Morn code thing. I've got to use their special swizzle. So the way they've done it. Oh, for crying out loud, I'll port that over, isn't it? Yeah, so the way they did their swizzle here, remap for wave reduction, there's a very special way they've done it. And this is, so it's kind of like a Morton Z curve, but it does it the other way around as well. So we need to take this. Yeah, okay. All right. So I've got to port this code over basically. Okay, where is it? So I wonder, right? Can I see this? Great. Okay, so I take all of these guys. That'll be good. So insert mask. We need that. Yeah, so we take these. And then we can swap out. Right, so that's in shaders. So our internal shared. Yeah. So we'll drop a new one in here. So E32 FFX bit field insert mask source insert bits. So mask equal 1 shift left bits take 1. I can't copy paste it because it's between 2 terminal sessions. And a mask ordered with source, not mask. Right, I guess, okay, they put extra brackets around just in case, but I don't know, probably doesn't need it. Cool. Nice. So the next one that is needed is the bitfield extract. And And then there's a bit field insert, is that it? No, just extract, perfect. So just one more of these silly things. So extract. So source offset bits. Mask, one shift left. Yep. Shift right. Return. Source offset board with. Sorry, ANDed with a mask. Nice. Right, so now we can port that silly old looking function. This one. Remap for FFX. Remap for wave reduction. Called it A for some reason. Cool. So it's actually a vector 2. So again, it's like a Morton curve thing, but it's kind of a little bit off from a Morton curve. So bit field insert. With a bit field. Extract. So it's A22, A23, sorry. With A and then 1. Nice. Now the next one, I guess we'll just copy this. Is an insert extract A33. Then another extract 1, 2. Then a 2 at the end. And voila. Right, so we take this. And we go to the downsampler, where we put in our Morton curve thing, but we can't use that because it's probably wrong. That's what we think the error is, so let's just give it a go and see if that is the fix. Right, it's mask. Did I say mark? What did I do? Oh, sorry, this is their code. Whoops. Right. I wrote the word mark instead of mask. Neat. Right, here we go. Conclusion, go to 3, please work. No! Right, so that might not actually be the problem, but we got it there at least. Yeah, so something's still a bit off. It's just jumpy, man. What's the issue with that? We can always change it back and then get rid of these guys later, but... Oh, what else could be the problem? It might come from 2 though. So if you're saying base MIP of 2 plus 1, it's actually to do with the 2 function. Just taking 2 then storing 3. Right, so it's actually to do with this 2 one actually. Just go back to the AMD source code and double check the 2 MIP 2 Right, this is probably the code that's wrong. Multiply by 8, then add half, slice mip. Seems sensible to me. Right, so maybe something that happened wrong in 0 and 1s. Okay, so let's go back to 0 and 1s and check this code. It's got a lot of code here which could be wrong. So I did change it to U32s instead of signed. Maybe that's it. Hey, Sully. Yeah, I know, right? There's spaces. Yeah, I just haven't changed them over. This is just the AMD source code I've nicked. I'm a tab man too. Tabs for the win. Right, so these are looking okay, I think. So times by 64, then add. How's it going, Sully? How you been, my friend? Load from the source image, right. It could be something to do with these base load source image things, maybe. We'll look at that in a sec. Let's just make sure this... So I reordered the parameters around such that the MIP came second last and the value went in last. That all looks pretty sensible to me. Why did not change much else? Oh, this is the ODS version. Get out of here. Get out. Alright. So it scales by 16. Each of them scale by 16, yes. And then +8, the other one's +8, and then both +8. Yeah. These got ones here. Right, but yeah, we upped them to 2 because we had to up it by 1. Rather than doing it in the store function, we do it beforehand. And then we stored intermediate. So that's 2. So we stored 2 out okay, right? But then we didn't change that store intermediate at all, did we? Right. Weird. Then this will do the load intermediate. At this point we've been able to reduce okay, so it's not really the reduces. So this is one that will store at the 3, but only one of them gets to write it out. Is the resolution just off? You know, it could be something like that. I don't know. We could try and make it square and see if that will fix it. Because they did say they had a limitation of a square texture or something. Like an odd numbered texture, but then that would just mean the borders, I think. I don't think this is the issue. Say we made it square. Does that fix it? I guess we can just do it manually. We can just resize the window and voila. Oh. So I bring up the profiler, tells us the resolution at the top left. Well, this will be a bit of an art to get it exactly right. Let's just get it off by 1. I don't think it's going to round up properly. We're well off there now, isn't it? There you go. Right, let's do that one. Apparently that's square. Doesn't look square to me. Alright, so if we go to... Yeah, 3 is still messed up. I don't think it's to do with the squareness of it. Some other problem. Yeah. Like if we comment out this code here, or we store it MIP, this will just mean that it is not yeah, 3D is not written out at all here, right? So we know it's that code that's failing. It's just the value that it's getting is, I don't think all of them are active. Maybe say all the quads, that uses quad intrinsics, doesn't it? Something like that. Is it actually waiting? Crap, I'm using a memory barrier. It's meant to be a control barrier, isn't it? Well, yeah, so control barrier means it waits. Memory barrier means it just flushes the cache. Perfect. Right, okay, good. Go down 4. I gotta side this thing. I swear it used to work, but now it doesn't. There you go, so run it. Gonna go down in 1 pixel, I think. It's not letting me zoom in anymore, but it seems alright. So eventually it gets white, basically. Just go to white because it's taken a max. No, wait, no. You go to white. Yeah, so we should look at this texture viewer as well, make that better. Alright, so a few things left to do. We got to... So I can write down a to-do list at least for next time. So where's that downsample? So what we need to end up doing is we want to, fix the texture viewer MIP changing code. So it zooms properly, etc. etc. Right, zooms and pans. That'd be nice. We've also got to sort out the so now that we've got it downsampled, yeah, we want to make a general way to create all the MIP, create GPU .h function that creates then re/initializes all of the texture views for a full MIP chain, something like that, because we're going to generally need that for the way the downsample function works. And what else? So after that, we also need to write the is occluded shader. It's just a function for shader code. Function to test like occlusion and things. Yeah, probably. Yeah, check things are occluded and make that wire that in properly. So that's basically what's left for the occlusion buffer stuff. So hopefully we can get this done next stream, or at least most of it. Yeah, I guess good progress. We've finally got the thing ported over. So yeah, I want to upload the code tonight, but the issue is I've got to get the Windows 1 working. Don't think I have the time for that, or I might do. Yeah, I think I can do that. Right, so yeah, thank you for everyone who's supporting the channel. Appreciate you guys supporting via Ko-Fi or Twitch. I'll get the code up tonight for you guys if you're interested in seeing that. Cool. So yeah, the next stream will be on Tuesday, about 4 hours. Wait, well, simple maths. 3 hours ago, but on Tuesday, and then 3 hours ago on Thursday. Well, we'll hopefully finish up the occlusion buffer on Tuesday. If not Thursday, we'll definitely finish that up. Yeah, I think it'll be Thursday, to be honest. This is going to be there'll be some glitches to sort out. And then after that, we can move on to, I've got made a list of things on the Discord. This month we would like to, yeah, we probably want to fix some of the glitches and stuff like with the Z fighting that's going on. Because the goal for the year is to make a renderer where we can render a bunch of ellipsoids where it's not got any horrible glitches and performance problems. So we'll probably fix those things and test out a high number of model instances and just see how well it goes. So that's what we're working on probably next Sunday. There. So very soon we'll be working on fading out small ellipsoids so we can probably have some more complicated models. Maybe we'll look into that. Or if not, we'll be using HDR and tone mapping and just making it so we can get some bloom going. You know, emissive will make things really pop. You know, so it won't just be changing the base color, it will actually be bright looking. You know, bloom and stuff. Cool, let's find someone to raid. I'm gonna go ahead and eat some food, I think. Ah, it's Raid Taylor. Excellent. Alright. So, have a good one, guys. I'll see you on a future one. Yeah, have a good start to your work week. Catch you later.